pre-algebra students, Mr. Lawrence here with your another flipped lesson. This one is the continuation of the number systems. Remember yesterday we talked about the natural numbers, right? Natural numbers, we use an N symbol. And remember, those were numbers like 1, 2, 3, on forever. No fractions, no decimals, right? And then we mentioned the whole numbers. And those were just like the naturals, except they also included 0. So they begin with 0 while the naturals begin with 1. But they proceed the same way. They don't include fractions, decimals, either. And then we got to the integers. That's where we talked about like owing people money. We got into negative numbers. So the integers were the ones that had no beginning. They include negatives, no fractions, no decimals, and they also include the positives and 0. All right. So you see, if a number is an integer, it might be natural or whole. Doesn't have to be, because these green ones aren't included in the naturals and wholes, right? But if a number is natural, does it have to be a whole number? Absolutely. Look at the 2, for example. The 2 shows up in the natural, it shows up in the whole, and it shows up in the integers. These little dots mean it goes forever. So if I pick a really large natural number, say like 3,625, that's going to show up in the wholes and in the integers eventually. So I'm color coding them. Now, to help you get a better understanding of this, sometimes we make a picture. I think I have the right one here. Hold on. Hocus pocus. There we go. We have a little circle or an oval, and that oval will be for our natural numbers. So I'm going to put an N in there, and I'm going to change the color of that to red. There we go, because we're doing them in red. And remember, the naturals began with 1, and 2, and 3, and then they went on forever, right? No fractions, no decimals, go on forever. All right, well, the whole numbers are around here somewhere. Let's see if I can find them. And we were doing ours in blue, I think, right? Okay. Yeah, I should change the color. And so those we call the whole numbers, right? And remember, the whole numbers start with 0, but that they also include 1, 2, 3 on forever. No fractions, no decimals. And notice that if I'm in the natural circle or oval, I'm automatically in the whole oval. All right. Then we talked about the integers. I'm not sure if I have the right one. That one's going to be too big. And the integers had no beginning because they included the negatives. They went forever in the negative direction. -3, -2, -1. But they weren't limited to that. They also included 0, just like the wholes. And then they included all of the naturals. Still no fractions or decimals. Okay, so hopefully this colorful visual will help you remember, if I'm a natural number, I have to be a whole number. You can see the red ones show up in the natural circle, but they also show up in the whole circle and the integer circle. All right, I'm also an integer if I'm a natural. If I'm whole, I have to be an integer. All right, but if I'm an integer, I don't have to be whole or natural. For example, -1, the green one, there are no green numbers here or here. Okay, we've got a couple more types of numbers to talk about. And first two, this is the rationals. The rationals. And the rationals include all the numbers above, but they also include all fractions and two very special types of decimals. Two types of decimals. The first type are decimals that end. The second type are decimals that repeat. And when I say repeat, I don't mean the same digit just has to show up once. I mean there has to be a pattern. For example, like 2.636363 is rational, even if it goes on forever like that. It's okay. Oh, by the way, a decimal then would be like 1 5/10, right? So 636363 on forever. This one here that I'm going to do now is not rational. 1.21314151. This is not rational. Yeah, it's true that the 1 is repeating, but the pattern is not repeating. It's not the same 2 or 3 numbers over and over again. So this guy is not rational. I'm going to get rid of him. All right, so let me see here. I think my notes might be a little bit too low. Okay, so our Venn diagram is starting to look like this, and the rationals include all those other numbers, but like all fractions and two very special type of decimals. Remember, decimals must either end or they repeat. Okay, and I don't have the room to squeeze it in there, so I will just go ahead and refer you back to your notes because I'm running out of room. So all fractions and decimals that end or repeat. Okay, so let me ask you this. Is the red one, from the natural numbers, is one going to show up in the rationals? Absolutely, because you could think about it as a decimal that repeats, like 1.0. 1 and 0/10 is the same as 1. It simplifies to it. So therefore, it's a rational number. Now, there's another group called the irrationals, and that's what this I is for. And I'm going to do the I somewhere different over here because those are irrational. And ir means not. So these numbers are not rational. They're a very special group of them. And right now in pre-algebra, it might seem like there's only a couple of them. And actually there are more of these than any of the other types we've ever talked about. But you'll learn about that later down the road if you keep studying math. That's a calculus kind of thing. All right, so irrationals. They are decimals that never end, and they never repeat. Okay, so the irrationals are decimals that never end and never repeat. Okay, I moved that note down below the Venn diagram just because I was running out of room. They're very special. Obviously, pi is probably the most famous, right? Pi is approximately 3.1415, but that puppy keeps on going forever without repetition. Now, that doesn't mean the digits don't repeat, like there's those two ones showing up. Okay, but notice it's not 141414 forever. Okay, so pi is not 3.14 as you might mistakenly believe. It's actually an irrational number, goes on forever. That one I did before what was it, 1, 2, 1, 3, 1, 4, ... that is irrational. Negative 7.0456 is irrational. Okay, and let's get those in our Venn diagram up here. Okay, so they're decimals that never end or never repeat. And the last one we have to talk about is real simple, and that's called the real numbers. Oops. And the real numbers just means the collection of all the natural, whole, integer, rational, and irrational numbers. They call them the real numbers because later on in Algebra 2 you'll learn about imaginary numbers. But for here, in this class, we're only going to deal with real numbers. All right, Mr. Lawrence signing off. Have a good night, everybody.